There are two critical problems today with AI agents running in your production environments: secrets exposure and uncontrolled agent behavior. Let's start with secrets exposure. When developers connect an LLM to applications through a normal MCP server, they generally paste the passwords, API keys, and tokens straight into the config file. This one decision drops long-lived, exposed secrets into the developer's environment and hands the agent open-ended access into critical systems. It is fast to set up and dangerous by design. Akeyless solves this by ensuring zero secrets are exposed to the LLM by using a secretless MCP connector that brokers all connections to applications. Now, let's move to the problem of uncontrolled agent behavior. Current approaches enable securing authentication and access, but they were not designed for autonomous AI agents. User intent does not equal LLM behavior in practice, which makes the outcome unpredictable and leaves your systems exposed to destructive actions by the LLM. Akeyless solves this problem. The Agentic Runtime Authority enforces security at the moment of action, not just at access, providing intent-aware authorization with dynamic access that checks and intercepts each request in real time, ensuring your systems are protected. Let's see the entire flow. It starts with a user prompt to an LLM for data in a database. The data request is made by the LLM. It is intercepted by the Agentic Runtime Authority, which checks the input as well as the LLM's permissions and intent. It then uses a just-in-time secret to access the database. The database sends back the requested information. The Runtime Authority then checks the output of the data to determine it is valid to return to the user, while ensuring that policies are enforced. Once approved, Agentic Runtime Authority allows the LLM to send the data back to the user. In summary, Agentic Runtime Authority ensures the agent holds zero credentials, which means there's nothing to steal. It provides real-time, intent-aware authorization by granting the agent least privileged permissions at the exact moment of action and continuously verifying them against the outcome. And in addition, it provides full traceability and logging of all actions performed by the agent on the target system from prompt to action. Let's see a short demo of the connector and runtime authority using Claude as our LLM. Claude has no access to our database credentials. Instead, it uses Akeyless's MCP connector to dynamically query our MySQL instance. Inside the Agentic Runtime Authority, we see that our guardrails enable Claude read-only permissions and deny access to salaries, as well as forcing email address output to be masked. Let's ask Claude to show us everything it has access to inside Akeyless. We see it can only access the MySQL database secret. Now let's ask it to show us all the data inside the MySQL employees table. The Agentic Runtime Authority instantly intercepts the request at runtime, forcing the LLM to comply with our guardrails and defining what it has access to in the table. It therefore only outputs data it is allowed to access. Let's remove the policy on salaries from within the Agentic Runtime Authority. We can now go back and prompt Claude for all the data in the table, and it will give us the complete output. Going back to Akeyless, we can also see the Agentic Runtime Authority logs and check the traceability of each session. By clicking on the three dots and then Forensic Traceability, you can see we have a request for this session that was blocked, and then 3 requests that were approved, as well as the actual database queries from the LLM. This is essential to ensuring policy controls for secure agent execution. Thanks for watching.